Let me ask you something. When was the last time you genuinely worried that AI might be coming for your engineering job? Maybe you saw some headlines, AI replaces hundreds of engineers at one company. Maybe you used a tool to draft a test report to speed up a design review and thought, wait, if AI can do this, what am I actually here for? That's a real question, and I'm not going to dismiss it. Because yes, AI is genuinely replacing certain engineering tasks right now. Routine simulation setups, documentation drafts, repetitive analysis work. I see this in my own field in power electronics design for electric cars. But here is what the headlines consistently miss. There's a specific set of engineering roles where AI is not a threat. In fact, it is making the humans in those roles more valuable, more necessary, and harder to replace every single year. Today, I'm going to walk you through 5 of them, what they involve, why AI structurally cannot take them, and most importantly, how you can position yourself inside one as an engineer. Because the engineers who figure this out early are the ones running programs in 10 years, not updating their CVs in a panic. Before we get into these 5 roles, if you want more content like this, built for engineers who are serious about building a long career that actually pays, hit that subscribe button right now. It helps the channel to grow, and you will get more of this content directly in your feed. Role number 1, system architect. In software, people call it enterprise architect. In hardware, in power electronics, this is the engineer who decides the fundamental structure of what you are building. What topology to use, what switching strategy, how the unit interfaces with the rest of the vehicle, what goes on silicon and what stays off of it. When you're developing power electronics for electric cars, someone has to stand up and say, this is why we chose this approach over 3 other options that we evaluated. This is how every subsystem connects. And this is why this design will pass the certification in Europe, North America, or in China. That's not a calculation. That is a judgment call. It requires years of domain experience and understanding of what the customer actually needs, which is often different from what they put on the specification sheet. And the ability to defend that decision in a room full of people who have different opinions, different incentives, and different levels of technical depth. AI can generate topology options. It can run trade-off matrices on architectures it has been trained on. It can even summarize what worked in previous hardware generations. But AI cannot sit in a cross-functional technical review with a supplier pushing their preferred solution, a vehicle integration team under cost pressure, and a certification engineer with safety requirements, and make a call that satisfies all 3 while keeping the program on schedule. That requires a human with experience and accountability. The more experience you have, the better you do it. The better you do it, the more irreplaceable you become. If you're earlier in your career in any hardware domain, start thinking about the full system, not just your module. That is the habit that leads here. Role number 2, technical project manager. I want to be specific about what this role actually is, because it is widely misunderstood. A technical project manager is not a scheduler, not someone who runs weekly status calls and updates a Gantt chart. That's a coordinator. Important, but not what I am describing. A real technical project manager converts a target into a deliverable result. In power electronics development for electric cars where I am working, someone has to take a program objective, a timeline, a cost target, and a set of technical requirements, and make that happen across a team of engineers, suppliers, test labs, and regulators. All of that at the same time. What does that actually demand? First, enough technical understanding to know when an engineer's timeline is honest versus comfortable. Second, enough people reading ability to know when a supplier saying on track is actually true. Third, the skill to translate technical risk into a language leadership can act on. And fourth, the ability to make decisions under pressure when you do not have all of the information you want and the program cannot wait. I manage power electronics programs for one of the biggest car manufacturers in the world. And I can tell you, AI is genuinely useful in parts of this job, summarizing documents, drafting risk registers, preparing status templates. I use it. But no AI is running a critical review when multiple tracks are delayed, two suppliers are misaligned on requirements, and a major gateway is coming in 3 weeks. That requires a human who can diagnose what is actually broken and move to a group of people toward a solution in real time. This is a human skill, and it compounds with experience, and it commands a salary that reflects exactly how rare it is. If you're an engineer who is also good with people, this path deserves your serious attention. Rule number 3, functional safety engineer. In automotive power electronics, every high voltage system in an electric car goes through a mandatory safety process. Hazard analysis, risk assessment, safety goals, safety requirements traced all the way down through hardware and software. In automotive, we work under ISO 26262. It is not a guideline, it's a regulatory requirement with legal weight. And here is the part that makes this rule permanently human. If a system fails, if someone is hurt, a court, a regulator, a certification authority is looking for a human being who is accountable, someone whose name is on the analysis, someone who can be questioned, and who can defend every decision in that safety case, not a software tool, a person. AI can assist with safety documentation. It can flag inconsistencies in a requirement chain. These applications exist and are useful, but the judgment, what is acceptable risk level for this specific failure mode, in this specific use case, for this specific customer, how do we handle a deviation found late in the validation process? Those answers require a qualified human who understands the technology, the standard, and also the regulatory context, and who is prepared to own the call. Accountability cannot be delegated to an algorithm. That is precisely why this role will always need a person. From a pure career strategy standpoint, functional safety expertise is one of the most transferable skill sets in automotive and energy right now. It carries a significant salary premium, it's global in demand, and the barrier to entry, deep technical knowledge plus regulatory qualification, is exactly what the kind of barrier that AI cannot cross on your behalf. High demand, strong pay, legally protected from automation. Build toward this. Role number 4, engineering leadership. Team lead, chief engineer, director, VP of engineering. And here's the truth most engineers do not want to hear. The higher you climb in a technical organization, the safer you are from AI. Not less safe, more safe, every level up. I understand why engineers resist this. There's a belief, I had it myself too, that going extremely deep in one technical domain is a safer move, that becoming the best in the world in one specific narrow thing is what protects you. And the uncomfortable reality is pure technical depth in isolation is actually one of the most vulnerable positions as AI improves. Because AI is very good at depth. It retrieves, calculates, cross-references, and generates designs at a level that will keep improving. What AI is structurally poor at and will remain poor at is depth combined with breadth, combined with judgment, and combined with accountability. A chief engineer or engineering director synthesizes technical reality, business constraints, team capacity, regulatory requirements, and organizational dynamics, all simultaneously, and makes a call that affects real people's career, customer safety, and company money. I have watched what senior technical leaders actually do, and it looks nothing like the job description. It is making decisions under uncertainty, reading people, building trust, saying no when the whole room is saying yes. No algorithm can replace them. And the financial dimension, because this channel is about real wealth for engineers. The compensation curve at leadership level is not linear. It's steep. Salary, bonuses, equity, and career optionality all multiply at that level. Moving toward leadership intentionally is not abandoning your technical identity. It is the highest leverage way to use it. Rule number 5, regulatory and homologation engineer. Every power electronics system that goes into a production electric car anywhere in the world has to pass mandatory certification. EMC compliance, high voltage isolation test, electrical safety standards, charging requirements that differ between Europe, North America, and Asia. These are legal requirements and they are not optional. The engineer who truly understands those standards, not just in theory, but in practice, who can read a test report and identify the deviation before it becomes a 6-week delay, who knows how to write technical justification that gives a program a path forward instead of a rejection, that engineer is extraordinarily valuable to any development program. Here's why AI cannot replace them. Regulatory frameworks are written by humans, interpreted by humans, and enforced by humans at certification bodies and government agencies. The standards change, the interpretations evolve over time. What cleared certification in one market may fail in another one. When your product hits a problem at a test house with a production start date approaching, you need a human who has navigated that exact scenario before and built the credibility to work through it. AI can read a standard document. AI cannot build a working relationship with a certification body. AI cannot sit across from a regulatory engineer at a test lab and negotiate a path forward with context, credibility, and trust. This role is underrated. The engineers who specialize here are rare, globally in demand, and directly connected to whether a product ever reaches the market at all. This is real leverage, career leverage, financial leverage, the kind worth building toward. 5 roles, 5 career paths that AI is not coming for, and in most cases is actively making more valuable. System architect, technical project manager, functional safety engineer, engineering leadership, regulatory and homologation engineer. Here is what I want you to take from this video. The engineers who thrive in the next decade are not the ones who ignore AI. They are the ones who understand where human judgment, human accountability, and human relationships are irreplaceable, and who build their careers deliberately in those zones. That is what this channel is about. Engineering your career the way you engineer a system, with a clear target, with intention, by design, not by accident. Drop a comment right now. Which of these 5 roles are you closest to today? Or which one do you want to move toward? I read every single one and I reply. If you have not subscribed yet, do it now. There's a lot more coming for engineers who are building something real. I will see you in the next one.